Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you to the new lecture in NS 224 numerical analysis. In today's lecture, we are going to discuss secant method. So, if someone gives you a nonlinear equation, f of x is equal to 0, if I draw it graphically, it will give you a graph like that, where f of x is represented by that graph. Then if you plot the graph, then what you are trying to do, you are trying to find the point where the graph of the function touch x-axis, or where the function is 0, or you are trying to find the value of x where f of x, at that value the function is 0. Then we call that point the root of the function or the solution of the function. In the previous lectures, we have discussed bisection method and Newton-Raphson method, and also we have discussed that we can find the roots of though nonlinear equation, which could not be solved through analytical methods. We can find the approximate root through bisection method and Newton-Raphson method. But also we have discussed the drawbacks of bisection method and Newton-Raphson method. Bisection method is very time consuming method because the order of convergency of bisection method is 1. On the other hand, the order of the convergency of Newton-Raphson method is 2, which is very fastly converging method. But the drawback of Newton-Raphson method was that you need to find the derivative of the function, the nonlinear function. So not every function is differentiable, or it is sometimes it is very difficult and time consuming to find the derivative of that function. So the best part of secant method is you don't need to find the derivative of the function. You directly go through the scheme of the second method and you can find the root of the function through approximate root of the function through secant method. So to derive the scheme of the secant method, first of all, you need to recall the scheme of Newton-Raphson method, which is we have derived in the previous lecture, that the scheme of the Newton-Raphson method is xi plus 1 is equal to xi minus f of xi divided by f prime of xi. And also in the derivatives lecture, we have discussed that the mathematical definition of f prime of x is equal to limit del x tends to 0, f of x plus del x minus f of x divided by del x. So if we ignore this limiting term, limit del x tends to 0, then f prime of x will be approximately equal to f of xi minus f of xi minus 1 divided by xi minus xi minus 1. What is xi and xi minus 1? Xi and xi minus 1 is actually del x. Del x, the difference between the 2 points. And by substituting this value in the Newton-Raphson scheme and simplifying, we get the, after simplification, we get the scheme of the secant method. So it is very easy to find the scheme of the secant method from the Newton-Raphson method, but why we don't call it the modified Newton-Raphson method, and how it works? So to learn that how the secant method works, as we have discussed in the Newton-Raphson method, how Newton-Raphson method works. So we will learn how the secant method works. If we have a function f of x, a non-linear function, which cannot be solved through analytical methods, or which is very difficult to find the root of the function f of x through analytical method, or which is impossible, or which is very time consuming. So then we are coming towards the numerical methods. So to find the root of that function through secant method. So in the secant method, let us take initially two guesses xi and xi minus 1, as we know that that point will be xi comma f of xi, where f of xi represent that one height, and xi is the point on the x-axis, and that point will be xi minus 1 comma f of xi minus 1. And here also f of xi minus 1 represent this height, and xi minus 1 is the width from the origin on x-axis. So let us consider that that point is A, that point is B, and the last one point at xi is C, that one point is D, and that one point is E. So that secant line which touch the graph of the function at 2 points, sorry. So the secant line touch the x-axis at xi plus 1, and the if we draw if we look at the drawing, A, B, E, and the drawing A, C, D. So from the drawing, uh, ABE and ACD triangles are similar. What does it mean? It means that if the angles of the triangles are similar, all the same, all the angles of the triangle are same, then the triangles are called similar triangles. And we have a theorem, if two triangles are similar, then this height divided by this height is which is CD, CD divided by BE is equal to the this length, AC length, divided by the AB length, the base of the another triangle. So from the theorem, if we have two similar triangles, then the height of the one triangle divided by the height of the another triangle, and the base of the one triangle is divided by the base of the another triangle are equivalent. So what is CD, the height of the large triangle, is f of xi divide by what is the height of the smallest triangle. The height of the smallest triangle is f of xi minus 1, which is equivalent to the base AC. What is AC? AC is the difference between these 2 points, x2 by x2 minus x1. We have xi minus xi plus 1 divided by that one base, which is x by x2 minus x1. We have xi minus 1 minus xi plus 1. So here we have, as we know that we have taken the initial guess xi and xi minus 1. So these 2 points are known. These are our initial guesses, as we have find for the bisection method the initial guesses that are that initial guesses. So these are that initial guesses, and what we have, we can find through that initial guesses f of xi and f of xi minus 1 as well. And what is xi plus 1? Xi plus 1 is the only unknown, which is the point where the secant line touch the x-axis. So we need to find the xi plus 1. This is our target. And as you see that we are going toward the root of the function. So from the diagram we have f of xi divided by f of xi minus 1 is equal to xi minus xi plus 1 divided by xi minus 1 into xi plus 1. So after cross multiplication, what we have f of xi into xi minus 1 minus f of minus xi plus 1 is equal to f of xi minus 1 into xi minus xi minus xi plus 1, and we are behind this term. So after multiplying this f of xi to these two terms and this f of xi minus 1 to these two, what will we get? We will get f of xi into xi minus 1 minus f of xi into xi plus 1 is equal to x f of xi minus 1 into xi minus f of xi minus 1 into xi plus 1. After rearranging the term, what we have shift this term to left side and this term to right side. So we get f of xi minus 1 into xi plus 1, because after shifting the sign of this term become positive, and after shifting this term to the right side the sign of this term become negative. So this term is here and this term is here. So why we rearrange it? Because we are behind this xi plus 1, and the only way to find xi plus 1 is rearranging this term and taking xi plus 1 common. So after taking xi plus 1, we have f of xi xi plus 1 into f of xi minus 1 minus f of xi, which is equal to which is equal to f of xi minus 1 into xi minus f of xi into xi minus 1. After dividing both hand side by this term, what we get on the left side, we will get xi plus 1 after dividing by f of xi minus 1 minus f of xi, and this side by f of both the side by f of xi minus 1 minus f of xi. This term will be cancelled out with this term, and what will we get? Xi plus 1 is equal to f of xi minus 1 into xi minus f of xi into xi minus 1 f of xi minus 1 minus f of xi. If someone wants to use this scheme, so he can use this scheme as well. So to simplify this scheme to the standard form, what we need to do, we will add and subtract this term. After the algebra, after adding and subtracting this term, we will get 0, and it doesn't matter if someone add the additive identity with another function, because if we add 0 with any a where a belongs to a real number, we will get again a, because a is an 0 is an additive identity. And after adding and subtracting this term, we are just adding the identity to the numerator of the right side. So after adding and subtracting this term, now we can take xi from these two terms common. So I have take here xi common from these two terms. So what will we get? We will get f of xi minus 1 minus f of xi into xi, and from here we can take f of xi common. So what will we get? We will get f of xi into xi minus f of x. The f of xi, we have take f of xi common, so we will get xi minus 1 divide by. So if we have a plus b divide by c, so we can write it here as a divided by c plus b divided by c. So now I'm just doing that. Now I have write f of xi I minus 1 minus f of xi as the denominator of this term, and separately as the denominator of the another term. So what we have here, this term will be cancelled out with this term. What will we get? We will get xi plus f of xi into xi minus 1 divided by f of xi minus 1 minus f of xi. After rearranging the denominator, that we will get xi minus f of xi into xi minus 1 divided by f of xi minus f of xi minus 1. We have just taken negative sign from the f of xi minus 1. So what we have in the last step, we have f of xi minus f of xi minus 1. So after multiplying minus sign to this, what will we get? We will get f of xi minus 1 minus minus plus, or plus minus minus, we will get f of xi. So just we have take minus sign from the denominator of the second last step, and we get scheme for the secant method. Now going toward how to use this scheme to find the approximate root of a function. So let us see in the next slide. So let us take an example how to use secant method to find the root or the approximate root of a nonlinear equation. We have an equation to find the approximate root of f of x is equal to x cubed minus 5x plus 1, performing four iterations. Performing four iteration. First we what we need to do, we need to find the interval where the root of the function lies. So the root of the function lies, f of x lies in 0 1 interval. How can we find it? So as we have done it before, that you need to press the mode button in your calculator, then press 7 button, and you need to write in the same way the function, the given function in your calculator, f of x is equal to x cube minus 5x minus 5 alpha x plus 1. What you need to do, you need to construct a table for the function. Then from that table, using the intermediate value theorem, we have some terms that we can find from the table the interval where the root of the function lies. So just putting after putting your function in your calculator, just press equal button, then it will ask you the starting point of the table. So I will write minus 5, that to start my table from minus 5 up to 5, and the step size will be 1. So I will get the function values at different values of x from minus 5 up to 5 by fixing the step size 1. So at x is equal to minus 4, the function is minus 43. At x is equal to minus 3, the function is minus 11. At x is equal to minus 2, the function is 3. So one root of the function lies in the interval minus 3 and minus 2. Because the function has different sign at x is equal to minus 3 and minus 2, so using the previous concept, one at least one root of the function lies between minus 3 and minus 2, or in the interval minus 3 and minus 2. So there may be other roots, more than one roots. The function may have no roots, may have a unique root, and may have more infinitely many roots. So it have one root between in the interval minus 3 and minus 2, and the other root is in the interval 0 and 1, because at x is equal to 0, the function have positive value, and at x is equal to 1, the function have negative sign. So the another root lies between 0 and 1. So if someone asks you to find the root of the function, the positive root of the function, so you must need to take 0 and 1 your interval. Otherwise you can take -3 and -2 as the interval for finding the root of the function, or the initial guesses for finding the root of the function. So here I have take 0 and 1 the initial guesses to find the root of the function. So in the first iteration in step 2, you need to put I is equal to 1 in your secant method scheme. By substituting I is equal to 1, what we will get x1 plus 1. So we will get x2 is equal to x1 minus f of x1 into x1 minus 1 minus 1 is 0 minus x0 or x naught divided by f of x1 minus f of x naught. What is the value of x naught at x naught? X naught is equal to 0 and x1 is equal to 1. So at x naught, by substituting the value of x naught 0 in the function, what will we get? 0 cube is 0, 5 into 0 is 0. So we will get at x is equal to 0, we will get f of x is equal to 1. So I have right here f of x naught is equal to 1, and at x is equal to 1, 1 cube is 1 minus 5 into 1 is minus 5. So 1 plus 1 is 2 minus 5 is minus 3. So at x is equal to 1, the function is minus 3. After substituting these values, the value of x naught, x1 and f of x naught and f of x1 in this scheme, what will we get? We will get x2 is equal to 0.25. Now what we have the value of x2, the value of x1, the value of f of x naught and the value of f of x1. So for the second iteration, just put I is equal to 2 in the secant method scheme. Here you need to put I is equal to 2. By substituting I is equal to 2, what will we get? We will get x3 is equal to x2 minus f of x2 into x2 minus x1 divided by f of x2 minus f of x1. So we have the value of x2. The x2 value is 0.25. Also we have the value of x1. The x1 value is 1. We have the value of f of x1, which is minus 3. What we need to do? We need to find the value of the function at x is equal to x2. At x2 we need to find the value of the function. So then finding the value of f of x2, then you need to substitute all these values in this scheme and you will get the value of x3. In the same way, for the third iteration, you need to substitute I is equal to 3 in the scheme and you will get x4 is equal to x3 minus f of x3 into x3 minus x2 f of x3 minus f of x2. The only unknown value is f of x3 and you will get the value of f of x3 by substituting this value in the given function. You will get f of x3. So at x is equal to 3, f of x3 is equal to 0.074276, and by substituting all these values in the scheme you will get the value of x4. And at the fourth iteration, it is the approximate root of the given function using secant method. Let us see how to find the the roots of the function using calculator coding. So first you need to press the move button, then press one button to then you need to write this scheme in your calculator. So how to write this scheme in your calculator? So here we have two guesses. The first guess is xi and the second guess is xi minus 1. So let us take the first guess as a. So if I consider my first guess as a, so then x naught will be equal to a, and what will be x1? And x1 will be equal to b. So here in the scheme we have x1 minus f of x1 into x1 minus x0. You need to write this scheme in your calculator. So I am trying to write it. So alpha xi, so for xi I am using b, alpha b minus uh, what we have f of xi, so I'm using b for xi. So I will write this function in terms of b. So I will write here parenthesis open b cube, alpha b cube minus 5 time alpha b, or and plus 1 bracket close. So what is it? It is f of xi. So I have fixed xi is equal to b, so I get b cube minus f of b is equal to b cube minus 5b plus 1. And then according to the scheme we need to write xi minus xi minus. So as we have assigned xi to b, so I will write xi as b minus, and will assign xi minus 1 to a. So I will write a divide by f of xi. So I will rewrite this function as b cube alpha b cube minus 5 time alpha b plus 1 minus f of xi minus 1. So here I will write a cube. I will replace x by a because I have assigned xi to b and xi minus 1 to a. So f of xi minus 1 will be a cube minus 5 times a plus 1. So alpha a cube minus 5 times alpha a plus 1. So in the whole scheme, just you need to write these three terms, these three sections, first section, second section and third section according to the given equation. The whole other scheme will remains the same. So I have write it according to the given equation. Then you need to press the calc button and substitute the initial two guesses. X1 is equal to 1, so the second guess is 1. So I will write b is equal to 1 and a is equal to 0. After pressing the equal button, what will we get? We will get our first iteration, which is x2 is equal to 0.25. Just you need to write x2 is equal to 0.25. Now for the second iteration, what we have the interval x1 and x2, then once again you need to press the calc button, and after pressing the calc button, what is the value of b? The value of b is 0.25 now, and the value of a is 1. So we will write 0.25 is the value of b. Sorry, if you make a mistake, then you can press equal button. So the value of a is 0.25 and the value of a is 1. So after pressing the equal button, you will get your second iteration, which is 0.186, which is x3 is equal to 0.186441. For the third iteration, what you need to do, you need to substitute the value of x2 and x3. So your next interval is x2 and x3. In the first iteration, the interval is x0 and x1. In the second iteration, the interval is x2 and x1 and x2, and in the third iteration the interval will be x2 and x3, and in the fourth iteration the interval will be x3 and x4. I will write you the general form of for the interval, that what will be the interval for each iteration. Now we have the interval x3 is equal to 0.186441. So I will press the calc button and will replace the value of b by 0.186441, and the value of a is now 0.25. We will get our third iteration after pressing the equal button, which is 0.201736. For the fourth iteration you need to repeat the process. Now what is the value of b? The value of b is 0.201736, and the value of a will be 0.186441, and after pressing the equal button you will get your fourth iteration x5, the value of x5, and at the fourth iteration x5 is the approximate root of the function using secant method. So the general form for the general expression for the interval is xi minus 1 into xi. If you are performing the first iteration, then your interval will be x0 and x1, your initial guesses. If you are performing the second iteration, your guess will be 2 minus 1, 1 and 2, 1 and 2, x2 and x1, and you need to write the second value for b and the first value for a, and then after pressing the equal button you will get your iteration, the value of x, the next coming approximate value for the function, for the root of the function, just by pressing the equal button. If you have any ambiguity, you can contact me through my WhatsApp number, as I have mentioned on my Google Classroom, and you need to try these equation, these exercise on secant method to find the root of this function. So going toward the advantages and drawbacks. In the advantages, the rate of convergency of the secant method is greater than bisection method, that as I have discussed earlier, that the rate of the convergency of the secant method is less than Newton-Raphson method. The order of the convergency of bisection method is 1, and the order of the convergency of the secant method is 1.62, and the other order of the convergency of Newton-Raphson method is 2. So Newton-Raphson method is a very fastly converging method, but the secant method is better. Secant method is better than bisection method in convergency, and it does not require the use of the derivative, as we have discussed that in Newton-Raphson method we need to find the first we need to find the derivative of the function, and there may be a lot of difficulties, or there may be the function which is very time consuming to differentiate. So it is the advantage, the best part of this secant method, that we will avoid the derivative of the function. And the next advantage is it requires only one function evaluation per iteration. You need to find, as we have discussed here, that you need to find the f of x2 value, because in the previous information you have all other values was of the scheme except the f of x2. So the next one advantage, it requires only one function evaluation per iteration. But after learning the calculator programming, you don't need to find these one function in evaluation. Just you need to press the equal button and substituting the value, you will get your result. Now the drawbacks are it may not converge. You by performing the iteration, how do you know that the function or the system is diverging, the secant method is diverging? So as you have fixed your interval where the root of the function lies, so if the values of the approximate values of the root of the function jumps from that interval, stop there because the system is diverging. So the another disadvantage or the drawback of the secant method is there is no guaranteed error bound for the computed iteration. It may be greater, it may be small, but there is no guaranteed error bound as for the Newton-Raphson method and bisection method. There is an error bound. Raphson method is better than the secant method, but the only drawback of Newton-Raphson method is that you must need to have a very good command on derivative of the function. That how could you find the derivative of the function? The another drawback of this secant method is if you have initial two guesses xi and xi minus 1, and they have the same, they have same values at f of x. If the height of the function is same on the graph at two values, then what will you get? You will get 0 in the scheme at f of xi minus f of xi minus 1, and the division by 0 will take you toward the divergence. So it is the another drawback of secant method. So this was a secant method. You need to solve the exercise. I will upload it to the Google Classroom. You have to try your best. Otherwise, if you have any ambiguity, so you can contact me frequently through my WhatsApp number or through my through the Google Classroom. See you in the next lecture.